Hello students, once again welcome to PU online bridge course. So yesterday we discussed how to write the chemical formula by using a crisscross method. I think all of you understood that method, and already I gave one exercise for you to complete the table related to this exam. Already I explained with Na plus with all the ions NaCl, Na2CO3, NaOH, Na2SO4, Na3PO4 and NaNO3. I explained the same manner. If you want to complete the remaining NH4Cl, we will get NH4Cl, NH4CO3. Yes, you can exchange the charges. You will get NH4 twice CO3, NH4 plus an OH minus. You will get NH4 OH, NH4 plus an SO4 minus 2. Exchange the charges. You will get NH4 twice SO4. Here also, here 3 is there. Here 1. You will have NH4 twice PO4, and this is NO3 minus an NH4 plus. You will get NH4 NO3. So these are the different combinations. You can see just like this: sodium chloride, ammonium chloride, potassium chloride, calcium chloride, magnesium chloride, zinc chloride, ferric chloride, and hydrochloric acid, hydrogen chloride, sodium carbonate, ammonium carbonate, potassium carbonate, calcium carbonate, magnesium carbonate, zinc carbonate, iron carbonate, and it is H2CO3, carbonic acid. Okay, you can say hydrogen carbonate, sodium hydroxide, ammonium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide, zinc hydroxide, and ferric hydroxide, and water. So these you can see OH minus is there. All these up to here what we are calling, these are bases solvent. Come to this one with sulfate: sodium sulfate, ammonium sulfate, potassium sulfate, calcium sulfate, magnesium sulfate, zinc sulfate, iron sulfate, and you can say sulfuric acid. Okay, now you can see with phosphate: sodium phosphate, ammonium phosphate, potassium phosphate, calcium phosphate, magnesium phosphate, zinc phosphate, iron phosphate, and H3PO4, phosphoric acid. Clear? Now come to this one with NO3 minus: sodium nitrate, ammonium nitrate, potassium nitrate, calcium nitrate, magnesium nitrate, zinc nitrate, iron nitrate. Finally got HNO3. This is nitric acid. You can see the last column. Last column, all you can observe, all these are acids only: nitric acid, phosphoric acid, sulfuric acid, water, and we have carbonic acid and what? HCl, hydrogen chloride or hydrochloric acid. So in this way, we have to write all the chemical formulas by using a crisscross method. Okay, yes, you can copy this table if you did not practice. So the next concept is acids, bases, and salts. Just you have to know general introductions to acids, bases, and salts. Let the first one we have acid. Okay, generally we can see the properties of acid. Generally, acids are sour in taste. Acids are what? Acids are sour. Sour in taste only. Generally, you know the basic identification, the litmus test only. It changes blue litmus to what? Red litmus. So they are sour in taste. So they will change blue litmus to what? They will change into red litmus only. Generally, how can you define acid? Means we have different theories of acids are there. The basic theory given the definition related to acid means that is Arrhenius acid base theory. So what is Arrhenius acid base theory? Means the substance which give H plus ions in aqueous solution, that is called as what? Acetone. Okay, acid is a substance which gives H plus ions. H plus ions in aqueous solution, that is calling as a acetone. So what type of compound generally comes under this category, which we can take HCl, H2SO4, HNO3, CH3COOH, H2CO3, H3PO4, etc. If these compounds, suppose in aqueous solution, they give H plus ion. So all these are examples for which one? Acid soap. Okay. So generally, what is the range of this acid related to pH? Means the pH of acid range between 0 to 7. 0 to what? 7. So this is mainly introduction regarding acid soap. So day to day life, we are observing different types of the acids. If you want to see the fruits, citrus fruits are there, they contain some citric acid. If you want to take a vinegar, that is also what? Acetic acid only. So all these are what tests we have? Sour taste. So those comes under what here? Acids only. Okay. So acid is a substance which give H plus ions in aqueous solution. These are the example. The pH of acid between what? 0 to 7. Come to the next one, we have bases. Okay. So what is a base? Generally bases are bitter in taste. Bitter in taste. Generally you can observe they are soapy to touch. If you want to touch that base compound, they are having some soapy touch. Okay. Now you can see here how they will change the litmus paper. Red litmus paper change into blue litmus paper. Red litmus change into what? Blue litmus paper. How can we define this base according to Arrhenius acid base theory? The substance which give OH minus ions in an aqueous solution. Okay, base is the substance which gives OH minus ions. OH minus ions we also called as hydroxyl ions. Base is the substance which gives OH minus ions in aqueous solution. In aqueous solution. What are the examples for this bases? You have to take NaOH, KOH, MgOH twice, AlOH twice, and FeOH twice, NH4OH, etc. Sodium hydroxide, potassium hydroxide, magnesium hydroxide, aluminum hydroxide, ferric hydroxide, and ammonium hydroxide. And all these are examples for which one? Bases. So generally, what is the range of pH of these bases? The bases in the pH range we have 7 to 14. What is the range? 7 to 14. So this is regarding about which one? Bases only. Clear? Now we have one more also there, that is salt form. Okay, salts. Generally, how the salts are formed out? Generally, salts are formed by reaction between an acid and base only. Clear? When acid and base combine together to form what? Salts only. Okay, how they are formed generally? Salts are formed by reaction between acid and base. reaction between acid and base only. So they does not change blue litmus to red litmus or red litmus to what? Blue litmus only. Okay, does not change blue to red, blue litmus to red litmus or red litmus to blue litmus. Simply we can say there is no litmus test for this compound. Okay, so generally what are the examples for the salts? We have different salts are there. NaCl, KCl, MgCl2, CaCl2, ZnCl2, AgCl, and we have AlCl3, etc. All these are examples which one salts only. Sodium chloride, potassium chloride, magnesium chloride, calcium chloride, zinc chloride, and AgCl, silver chloride, and we have AlCl3. All these are examples which one salt only. What is the pH of this compound? Means pH is equal to exactly 7. So this is introduction to which one means acids, bases, and salts. So acid, we have 3 types of acids is there. That is monobasic acid, dibasic acid, and tribasic acid. Monobasic acid, dibasic acid, and tribasic acid. What is monobasic acid? Means the acid which give only one H plus ion. The acid which give only one H plus ions, or the replacement of hydrogen take place how many means here? 1 only. Okay, so we can give acid which gives one replaceable. Okay, one replaceable H plus ion is comes under which one? Monobasic acid. Let us say example we have HCl. Here, HCl dissociate into H plus and Cl minus. How many H plus ions are observed here? 1 only. So they give only 1 H plus ion. Simply we are writing here basicity is equal to 1 mole. Let us say one more example. We have nitric acid HNO. Nitric acid dissociated to H plus and NO3 minus. So what is the basicity you will get? Means the basicity how much here? 1 only. You can take HCl, HNO3, and you can take CH3COOH. Comes under what type of acid? Means those comes under monobasic acid. What is the basicity? The replaceable. Okay, the number of replaceable items is called as basicity. Basicity we are using for which one? Acid. Come to this one, dibasic acid. Di, the name itself is there. Di is how much here? 2 only. The acid which you 2 replaceable H plus ions only. Okay, the acid which gives 2 replaceable H plus ions is called as what? Dibasic acid. Let us see the example. We have sulfuric acid. Sulfuric acid dissociate to give 2H plus SO4 2 minus. 2H plus SO4 2 minus. Here how many replaceable hydrogens we have? 2 replaceable hydrogens. So from this I am writing here basicity is equal to 2. Basicity is equal to what? 2. Come to this one, H2CO3 we have. H2CO3, that is carbonic acid. It dissociates to give 2H plus CO3 minus 2. What is the basicity of this acid? Here also 2 because it gives 2 H plus ions. Okay. And one more we have H2C2O4. This is called an oxalic acid. H2C2O4. It dissociates to give 2H plus C2O4 minus 2. So here also how many replaceable H plus ions we have? Okay, we have 2 replaceable H plus ions. So these three comes under what type of example we have? Dibasic acid salt. For the last one we have tribasic acid. So tribasic acid means what? Acid which gives 3 replaceable H plus ions. Acid which gives 3 replaceable H plus ions is called as what here? Tribasic acid. Very example we have H3PO4. This is a phosphoric acid. It dissociates to give 3H plus PO4 minus 3. So here what is the basicity? The basicity how much? 3 ohm. So these are different types of acids we have. Monobasic acid, dibasic acid and tribasic acid. So this classification mainly based on what? Number of replaceable H plus ions. Next we have the bases. Again like this. So bases also classified like this in a 3 types depending upon the replaceable OH minus ions. Okay, so let us see we have bases. Again the classification mainly based on which? Number of replaceable OH minus ions. Okay, the first one we have monoacidic base. The first one we have monoacidic base. So what is meant by this monoacidic base? Monoacidic base. So monoacidic base means the base which gives 1 replaceable OH minus ions. Okay, simply we can write the definition like this: base which gives 1 replaceable OH minus ion. Clear? What the example you are taking means you can take NaOH. NaOH dissociates to give Na plus and OH minus. If you want to take here KOH, dissociate to give K plus and what? OH minus. If you want to take NH4OH, dissociate into NH4 plus and what? OH minus ions. In all these compounds, how many OH minus ions are replaced? Means that is 1. So this comes under one example we have monoacidic bases. So for bases we are writing here acidity. Okay, acidity is equal to 1. Okay, here in all the columns we can write acidity is equal to 1. What is meant by acidity? Generally, acidity means number of replaceable OH minus ions we are finding for what compound means for the bases form. Clear? And the next one we have diacidic base. Diacidic base we have base which gives okay 2 replaceable OH minus ions. Let us take an example. We have magnesium hydroxide. It dissociates into Mg plus 2 plus 2 OH minus. Magnesium hydroxide dissociates into Mg plus 2 plus 2 OH minus. Here how many OH minus ions we have? 2. So what is the acidity? Acidity is 2 of. Acidity is equal to 2. If you want to take here zinc hydroxide, okay, it dissociates into Zn plus 2 and 2 OH minus. Here also acidity how much? The acidity is how much here? 2. If you want to take here calcium hydroxide, we have it dissociates into Ca2 plus and what? OH minus. Here also what is the acidity we have? The acidity is how much here? 2 only. So this comes under what? Diacidic bases. First one is monoacidic bases. Second one we have diacidic base, and one more is there, that is triacidic base. So the next one we have triacidic base. What is triacidic base? The base which gives 3 replaceable OH minus ions. Okay. What are the example for this one? Means I want to take here aluminum hydroxide, AlOH thrice. It will be dissociated into Al3 plus 3 OH minus. Al plus 3 plus 3 OH minus. What is the acidity for this compound? Means acidity is equal to 3 O. Clear? If you want to take here FeOH taken 3 times. Okay, ferric hydroxide, it will be dissociated into Fe plus 3 plus 3 OH minus. Here also what is the acidity we have? Acidity we have how much? 3 mole. So these are comes under what? Triacidic bases. So based on the number of replaceable OH minus ions. So bases are classified into 3 types. That is monoacidic base, diacidic base, and triacidic base. We already discussed. So the next concept related to another one we have salts. Salts already discussed. Okay, I already told you salts are formed by the chemical reaction between one we have acids and what? Bases only. When acid and base combine to form what? Form salt and water. That reaction we are calling as a neutralization reaction. What reaction? Neutralization reaction. How salts are formed? When acid and base, okay, they are combined to form what? Salt plus water. Salt plus water. This reaction generally what we are calling neutralization reaction. Let us see one example we have. I am taking here HCl reaction with NaOH. It gives rise to NaOH. NaCl plus H2O. Okay. What is the compound we got here? NaCl. NaCl is dissociated to give generally Na plus and what? Cl minus O. So what is the charge of Na plus? Means Na plus having a positive charge and Cl having a negative charge. Okay. Na plus we are calling as a generally cation. Okay. The positively charged species we are calling as a cation only. Negatively charged species we are calling as a anion. Okay. And let us see one more. I am writing here acid radical. Acid radical is there, and one more we have basic radical is there. Okay. From this, what is the acid radical and what is the basic radical we have? Okay. Here Cl minus is there. This Cl minus is coming from which one? Acid only. So what is the acid radical in this one? Cl minus is the acid radical because it is coming from the acid. What is the acid radical we have? Cl minus one. Basic radical, the radical which is coming from the base. Here NaOH is the base only. NaOH is associated to give Na plus OH minus ion only. So what is the basic radical in this reaction? Means here Na plus is the basic radical. Okay, cation is Na plus, anion is Cl minus, acid radical is Cl minus, and basic radical is what? Na plus O. Let us see we have one more example. HCl plus NH4OH. HCl plus what? NH4OH. It gives rise to one of the compound we have NH4Cl plus what? H2O. NH4Cl plus what? H2O. This NH4Cl we are calling as a salt. What is the name of the salt? Means it is ammonium chloride. Ammonium chloride. this ammonium chloride dissociates to give NH4 plus what man? Cl minus 1. So which is acid radical, which is basic radical means Cl minus is said to be acid radical. Cl minus is said to be acid radical. NH4 plus is said to be what radical man? Basic radical. Basic radical. So in this way we have to identify if you have salt is there. The salt is composed of what type of cations or what type of anions. The salt contains what type of radical. Okay, what type of radical? The radical may be acid radical or the radical may be what? Basic radical. So this is regarding about which one we have salt.